Awesome. Hello, everybody, and thank you so much for joining our live stream here on the Aqua Security Open Source channel, where we talk about our open source tools, mainly Trivy and Tracee. Now, this is a Tracee live stream where we share updates from the latest release of Tracee. My name is Anis Ulis. I'm the open source developer advocate here at Aqua, and I'm just going to moderate this live stream. Now, we're going to have everybody from the core team, from the core Tracee team, joining us. So do ask your questions either in the live chat or if you're watching the recording in the comments, or do join also our Slack community and ask your questions there in the Tracee channel or in the GitHub discussions, or create an issue. Lots of places where you can share your thoughts and questions. Now, we have a little bit of a structure, but before we get there, before I bring on everybody from the Tracee team, please bear in mind that we have a code of conduct, and be respectful and follow the code of conduct with all of your interactions across our open source channels and any Aqua-related channels. Now, I'm going to just bring everybody on. Oops, not your stream. So, and then we can go around. So here, these are the main people I get to work with on a day-to-day basis. Very exciting. Now, let's just go around and just introduce yourself of who you are. I mean, people know that you work at Tracee, but maybe a little bit more of what you do at Tracee, with Tracee on a day-to-day basis, what aspects maybe you cover of the project. Maybe something you want to share on your background, and a fun fact about yourself, or or your favorite open source project that is not Tracee, just so people can get to know you a little bit better on what you do and what you work on. Jose, you want to get started?
Sure. I'm Jose. I work on the Tracee team, and what I do is I create bugs, so my teammates have to fix it. Joking. Favorite project right now, I think that's not Tracee. Like, I think like the one I have been studying the most is Parka. So really like the project. And I don't know, fun fact, I'm using a Tracee t-shirt. So that's it.
Awesome. Thank you. Yaniv?
Hi, everyone. So yeah, I'm Yaniv, and I'm leading the Tracee team. One thing you might have not know about me is that before I joined the open source team, I was in the security research team, where we also created the Tracee project. And here we are now.
Amazing. Favorite open source project that's not Tracee?
I think it would be Runcy.
Okay. Raphael?
Hello, I'm Rafael. I also work at the Tracee team for about 1 year and a half, I think now. I came from like lots of different backgrounds. A fun fact from me, I think I started looking for Tracee when I was working in another company, like trying to implement it, and then I was invited to create the features that I was asking for at that time. Yaniv was at research, so it was fun because instead of like using it, he invited me to join the team and start and help building it. And the project I like most, I would say, mainframes. I have a very like emotional things with mainframes. I used to work with S390 architecture, so I would say like all the projects related to mainframes.
Awesome. And Gislan?
Hey folks, I am Gislan Gregorio. I will start with a fun fact. I haven't been in the IT industry my whole life, so my first professional years were as a software developer, okay, but due to the regional impossibilities, I had to work in the banking sector, and then as a government employee here in Brazil. But several years ago, I returned to the area I love. And for the last 8 months, I'm doing this incredible BPF stuff at Aqua, playing Tracee and BPF Go with this awesome team. every day.
Amazing. So you
That's
used
it.
to be a suit person.
Sorry?
You used to be a suit person
Yeah,
working in
exactly.
bank, eh? Okay. Great. Thank you.
Never more, never more.
Never more.
Never
Not
again.
again. Cool. So, does anybody, whom of you wants to give kind of an overview of the latest Tracee changes? What's new in Tracee? And then we can go from there.
Yes, I
Yeah.
think I can take that. So it's actually Tracee is going through a lot recently. Well, it started from being, I don't know if you know the start of Tracee. So back then we only had Tracee BPF, and Tracee BPF was used to get events out of the kernel. After that, we created Tracee rules, and then we had the Tracee output become the detections, which were coming from Tracee rules. And that was the main thing of Tracee up until recently. So in the last milestone, we introduced the new Tracee architecture, where Tracee BPF and Tracee rules are now became one binary. And in fact, you can combine now the raw events from the kernel in addition to the detection, and all of these became events. This is what we right now we call everything is an event. Can be thought of as an analogy to Linux. Everything is a file. So in Tracee, everything is an event. And now the raw events and the detection all become events. And in this milestone, we're going to also introduce policies in Tracee, which is a new concept, and Jose will give some example later. And we're also going to introduce some user-friendly events, which will make the raw events more easier to understand and use. Yeah, so I think that's it.
Muted. Amazing. Thank you. Cool. So, Jose, do you want to jump in to give the demo first on the policies, new policies that people can define there?
Sure.
Should I share the screen?
Yeah. Okay, policies. This is what coming in this release. Like basically the last few features I was working on was like leading to policies. So yeah, and you mentioned like now everything's an event, and we have like a single binary architecture. So before we would have like we had two binaries, now it's just Tracee, and if you do L, you see like all the events, right? And not just the events that, for example, system calls, things that happen in the kernel, but also what we call signature events, which are created by like the research team at Aqua, the security research team at Aqua, to identify like possible breaches and everything, and other events like network and everything. So before everything would on Tracee would be done like through the command line. So someone would do like a filter and say that he wants scat process exec as an event. And now we are changing this to support policies. So let me show an example of a policy. So if you want, I'll name it. So policy one, simple description, that's policy. I'm gonna add a default action. For now, it's logging only. I scope. I'll explain scope better later. For now, I'll just say like it's global. It's for the whole host, and rules, right? What are the events I want? For this case, I'm gonna do the same thing I did on the command line, get process exec, and it's like basically trying to do the same thing we did here, but with a policy. And now we can do dash p, that's this policy, and it's tracing the same thing it was tracing before, but now with the policy. Let me just say I want JSON here, so it can show you here that like okay, so I want to show you the match policies. So the policy one was matched, right? So the event is cat process act, and this policy was matched. We could change this policy to add like other events. So for example, we can say, I also want the Tracee event and run it. So now we have this cat process act, and if I do a straight select here, I should have the Tracee event somewhere here, okay? And we can create like different policies. Right now we support like up to 64 policies, and each policy will match the set of events you configure. So just to copy this policy here, I'll create another one. But for this policy here, I just want trace, right? And I'll start and press the two policies. Oh, there's already a policy in one, so let me rename it. Okay, I'll run the trace ls, trace event again, and I'll match the policies showing like the ptrace event was matched like in two different policies, right? The policy one and the policy two. So this would be like the basic structure of the policy here. We support different scopes, different events, and different actions. So we are working to support like other actions like webhooks and Fluentd, but those are not implemented yet. For now, it's just policy. And for the scope, right? So I said like this policy here was for the whole host, but like I might want like to do something different. For example, maybe I want the ptrace only for new containers. So I can say that the scope is containers equal new. I'll pass this policy. Sorry, container. Started it. If I do the same as Tracee as before, it should not like catch anything because it's not for the whole host, right? Now it's just for the new containers. So instead we can do Docker run, Ubuntu, and I hope I have like a Tracee. So let me start with real quick. Stunning. Okay, almost there, folks. So now for the Tracee selects. Base was called just for the new container, right? So the scope is basically a way of saying like exactly what the name implies, right? What is the scope of the event you want to see, right? Do you want it for the whole host? Do you want it for containers only? There are several other filters you can have in the documentation. For example, we could do trace list, and we want all the DNS requests. So let's change our policy here. The event DNS request, but we want it for the binary. Let me get the binary so big. And I'll pass the binary here. Start Tracy. And run big. And we should get this event, and I can like mix scopes together, right? So for example, now we care about the binary, but maybe we wanted the binary and only for new containers, right? We don't want for the whole host. We want for that binary, that event for containers. If I do declare, it should not like raise anything because we're specifically configured for new containers. And if I run Docker again, I'll have to start it as well. Stalin, sorry about that. I should have like get a better image. It's not this. I forgot the name. Rafael, can you save me?
What is it? Better
To
term
install
for what?
Git? No, to install Git.
DNS,
Oh,
DNS YouTube.
DNS. Yeah, thank you. No. Okay. The good thing about having like Rafael on the team, like all the Linux questions, we can direct to him. He always can help us. So GitHub, boom. And now we have here just dig the specific binder just for that container, right? And but there are a lot of things we can do here. Like we can have several events. The last thing I want to do is like for signatures, right? Signature is something that the research team creates. Like the user can create his own signature, right? Let's suppose the user wants to know like he wants to create a specific signature for when a file is returned something. So I have a sample here.
Wait, for people watching this for the first time and don't know what a signature is, can you provide more getting started explanation of like signatures?
Okay, so yeah, Tracee has like a collecting events, right? But some of the events we have in Tracee, they are designed as signatures. Basically, the intent is the research team, the security research team at Aqua, they, with their knowledge about like breaching and everything, they create specific signatures to detect like malicious behavior, right? So for example, here, a good example is like dropped executable. So this is a signature that will be triggered, like, right, is an event that will be triggered whenever something is installed in a container. Because the idea is like, if the container is running production, it should be immutable. There should be no new installation on it, right? It should be ready to run in production. So we have a signature to identify that behavior. The ones we have right now was designed with our research team, but the user can also create their own signatures if they want to. Does that make sense? So for
Yeah.
example, I have a sample signature here. I'm calling like just Rego test. It's like just base signature to know if a file was written or not, right? So the name I gave it to it was Rego test here. If I try to write a policy for it, so for example, P2, and I say Rego test, I'm gonna say that the scope is global here, and I start Tracy with this policy. JSON P2. So it would say the event doesn't exist here, right? Because I'm not passing, I'm not telling Trace where this signature exists. So we can say dash dash signatures here and pass the directory example signature. And now you're going to start retrieving that signature, right? So the events are not just only like syscall, kprobes, things that are happening in the kernel, are also the signatures that the Aqua research team are creating, but like the user can create his own if he wants to. And we have like some examples that are mentioned on Trace right now. If you go on GitHub, it's coming with this release that will show like different things. For example, I demonstrate that its scope, it will work for, you can say like different scope, right? Is it global? Is it for new containers? Like this set of filters with even more like possibilities, I also support per event. So for example, on this policy here, we're saying the scope is global, but then we want the event read and event write, and we are filtering it per P. So like we also can filter different events based on different criteria. PID, process name, user ID. So there are a lot of different filters. Also can find it on our documentation, but you can do filtering per scope. We can say the scope is this, but also depending on the event, you can filter event for different things, right? So I want the read just for the user's hood. I want the write just for the user Jose or something like that. And that is my demo. Any questions?
Could you, if there are any questions from the people watching, then please do post them in the chat. Anything related to the demo as well as Tracy, and we will address them. Now, could you just summarize the benefits of our approach of writing policies? And you mentioned a few while you were talking, but just, I guess, summarizing the benefits or like of
The
this way of
benefits.
writing policies and versus like this approach, this workflow, I guess, versus what we had before in Tracy.
Yeah, so I think like policies allow us to create like way more specific things, right? That we before with the command line was not like the user experience was bad because you have to type a lot and like you couldn't store it on GitHub or something, right? So for example, we have a lab project called Tracee Action, and right now everything we want to try to do it, we have to like create in the command line and like maintaining it was really hard. And with policy, this becomes really simple because I can have like 3, 4 policies to do what I need, and I can create like I can extend it to be very specific, but at the same time very global, right? So uh, is nothing that like Tracy already did it before, but I think like with the command line was a really bad experience for the user on how to use it and how to implement the features, what he's trying to do with Tracy, and policies like give like a better user experience of how to express that.
Mm-hmm.
I want to add one thing on what on top what Jose said. So the idea behind policies is that you can say for this scope, I'm interested to see these events, while scope defines the workload you're interested at looking at some events. Now we call them actually rules because you specify each rule contains 3 fields, which are the event, the filter that you want to relate to this event. You can filter by the context of the event, like UID, PID, and such stuff. You can filter by the arguments of the event. So these filters are available, and if event is matched, you can take some action. So action is one thing that currently we support only log, which correlates to what we had up until now in the command line, but in the future we will add other actions, and actions are only available through the policies and not through the command line. So like I said, policy attach some scope to some events and rules actually. And then not only you can specify one policy, so you can specify different policies in the same time, and each policy will be applied on a different scope. And according to the scope, if it matched, the rules will be applied according if there is a match or not. That's the idea.
Makes sense. Thank you for sharing. Jose, you want to add something? No? Good.
No, yeah.
Could you then just with these changes, is there a change in how people are supposed to use it in the workflow? Could you just describe the workflow of somebody like you install Tracy, for example, inside of your cluster? What steps do you do then? What do you do like step by step of like when do you set up the policy? How do you get it inside the cluster, for example, or like Tracy to respond to it? And just can you describe that workflow?
Yeah, so like the policies to a new feature. So like there are things we're gonna improve, like especially if we're talking about Kubernetes, right? Right now, the way you would do it, like we have a few examples and we have like a set of default events, right? And when you have your cluster, you would create like a config map where you pass those YAMLs, right? Like those are the policies that you want to use. And using the Kubernetes volume configuration, you say this config map is mounted here. And you can here, for example, we're passing just like this Tracy P and one policy, right? But we can also pass like a directory with a bunch of policies, and all those policies will load. This is something that definitely we're going to improve for the next release because we introduced policy right now and it's not there yet the way we want. But right, this would be the basic flow, right? It's coming later, CRD, and like once you apply it, Tracy will reload itself. So this is coming is in the plan, but right now you would have to use the config map.
Makes sense. Awesome. Thank you. If there are any questions from the people watching, do post them in the chat. Anything related to Tracy, to the developments, maybe roadmap, or to the demos that we're showing here. Otherwise, I'm going to move on to Raphael, who has another demo he's going to share. Are you sharing this? You were changing around your screen, Raphael, so I wasn't sure. There's one
I'm
question
sorry. Go
before we
ahead.
go
I'll check.
to you.
Yeah.
Shubham is asking, did the idea of policies originate due to their declarative nature, popular in Kate's YAML file, and maybe the ability to commit to Git as well easily? Or what drove, I guess, the development of policies? Was it people complaining about the previous experience? What led to us creating policies and changing
Yeah,
Tracy around?
I can answer that. So I think it relates to what I previously said, that when using the command line, so the command line used to be, okay, I have these filters, this is what interests me, and then you get the events. So right now with policy, you have the ability to specify different scopes, and then for each one of these different scopes, you can specify different rules. So it's much easier to specify different scope and rules using these policy files, where each policy file specify some workload you want to apply the policy for. So this is one thing. The second thing relates to the actions, which is much better to write, like I said, declarative nature. It's much easier to specify, okay, I have this event, and then I want to take this action. One example for that we plan to implement in the near future is, for example, blocking network traffic. Rafael will probably say a bit more about that later. So the idea is that you will be able to say, okay, I have the event of IPv4 packets and protocol TCP. So if I see that the port is different than 80, block. So it's much easier to do that through a policy. And like I said, also for Kubernetes, it's much easier to have a file which you can specify rather than the command line.
Awesome. I hope that answers the question. If you have any follow-up questions, do post them in the chat. Or in addition to the live stream, you can also join the Slack channel. I think the link is below in the description of the video. Otherwise, I'm going to share it afterwards and ask you questions in the Slack. Now, I'm going to share your screen, Raphael. Is that okay?
Yeah, sure.
Have you go? Okay. Oh, this is too small.
Is it?
A little bit too small. A little bit bigger, please. That should be working. That should be okay. If it's still
Is
too
it-
small for people watching, then please do let us know.
Okay.
So
Is
what
it
are you
too
going to
small?
share? Yeah, it works. I think that works.
Okay,
That's a
so
good sign.
first of all, before jumping into networking, I just wanted to mention a few things. So we're currently for this release preparing a bunch of supportability on ARM64. We're starting to support the architecture. Like Tracy has been working in ARM64 for a long time now, but we will start having the images for ARM64. So here it's an ARM64 machine at Amazon, and then you can see like simply adding your name at the end of the label. It will pick the specific architecture image, and then it will run Tracee in ARM64. So you could simply run, and it will start like. Let's see if this is the one. So as you can see, it's tracing the machine, an ARM64 machine. So this is one thing that I wanted to mention. The other thing that will be a feature for this release probably is also dropping capabilities by default, which we can talk later. But the idea is that Tracee won't run with privileged capabilities, and most of the times it will run with low capabilities and way more secure. And now let's jump into network. So I prepared like some comments for showing the network feature. So I will start by showing how the network events work, and then I can jump into specific details of each event if needed, or jump into capturing feature, which I wanted to mention as well. So in here, like there is the simplest way of tracing network events, right? So you basically say that you want to filter a net packet event, right? So as you can see, the net packet event in JSON output, right? So it's a simple IPv4 event with source and destination, and then you can see like IPv4 header, all the header fields in here, right? And then we have like many other network events, as you can see in here. So if I, let's say, execute this, now I'm tracing and I'm filtering for a bunch of network packet events, actually all of them, which includes IPv6, ICMP, TCP, UDP, etc. So I can trace, and then as you can see, like it's a bunch of packets. Since I'm using like local host communication, you can see a bunch of like local host communication, so it's hard to see what is going on. So I could, for example, filter out communication to local host in the same example. So I can do this, and then I'm filtering for net packet IPv4, but then I'm applying a filter to it, right? So I'm saying that the argument source shouldn't be localhost, right? And then when I execute this, I can see, let's say, something else. So I'm pinging the root server DNS. And then as you can see here, it's only the IPv4 event, right? Because that's the only event I have selected. But I could do like, for example, ICMP only, right? And I don't need like a filter because I'm not running ICMP in any other proxies in my machine. So if I ping, and you can see the ping happening, and like two events, it's the echo and reply, right? Just for this. So as you can see, like differently from IPv4 network events, you're gonna see the ICMP header values here. So this is basically the ICMP packet and all the fields from the ICMP header, right? So it's an echo request, it's an echo reply, and then the checksum, the ID, the sequence number of the packet, etc. Right? So this is the base idea for network events. And before jumping into how to capture communication, I wanted to show like what to do with those events, why we have the network events, and also explaining a little bit about like signatures. So for example, if I do this, I have separated like one of our network signatures, which I'm using for testing the DNS feature. And without going like into many details, but the idea is this signature will be triggered anytime that this sequence of events happen, right? So like if I'm running Tracee with this signature and I query the google.com for the mail server, MX, and then, okay, I just did that. And then I do another query for name server at google.com. And then I save the state. And then by the third query is like the SOA query for google.com as well. By the time I have the third query, I would consider this like, this is a harm, that's a behavior I wouldn't accept. And by the time that happens, the signature is triggered and the end user would know, okay, something bad happened. Of course, this is just an example, but the idea is that you can trace network events and create signatures on top of those. And the skeleton for this is like, in a very simple term, every time there is an event, and the event is a net packet DNS, I parse the DNS event. So I check if there were answers. And if there were answers, I check if the answer was an MX or like the DNS mail query. So if it was smt.google, I save the state. And then the query, if it was a name server query to Google as well, I save the state. And then the SOA. By the time the three states are true, I'm going to trigger the signature and say something bad happens. And the way to trigger the signature would be as simple as this, I do three NS lookups. And then by the time the third NS lookup happens, the signature is triggered. So this is just an example of how to use the network events. And now I can jump into capture if it was clear enough.
If there are any questions, do post them in the chat, as you can go ahead.
Okay, so the network capture feature is on top of all the network events, right? So the idea is this. So let me pick a command to capture DNS. So if I run this command here, I'm basically saying that I would like network packet DNS events, right? I'm clearing the capture there. I'm capturing network. So it will capture network into PCAP files, right? So you can read those files using TCP dump. And then I'm capturing in a single file. I'll enter in details on how to capture in multiple files or in other ways. But this is going to create a single PCAP file with capturing all the packets coming from anywhere in my server. Like I'm not filtering for a specific like proxies or anything, right? So when I run this, and let's see if I'm if I do this, you can see that there is a single PCAP file here, and then I can do TCP dump PCAP single PCAP file, and you can see that there is a bunch of like packets happening. And one of the things that you can notice is that not DNS packets like I requested, right? Because the capture will capture everything, not only what is being filtered. But I can change that behavior. So like, for example, if I want to capture only the network packet DNS and not all the traffic happening, I can add an option at the end, which will be PCAP options filtered. So what we'll do is that instead of capturing all the traffic, it's going to capture only what is being filtered, which in this case is only DNS packets, right? So when I run this, as you can see, there is like the no file created. Now I'm going to ping something so the DNS event happens. And then by the time the DNS query happened, I can see that the file was created. So I can see the file. And as you can see, This is a DNS query, and there are like DNS packets happening, and as you can see, like this is the root server answering for my my IP, so you can pretty much see everything that happened DNS related in that PCAP file. Okay, so this is like a simple simple example. I could, for example, instead of capturing everything in a single file, I can capture all the network events into multiple files. So, like for example, if I run this command, I'm basically picking and filtering for all the network events. And I'm telling Tracee to capture one PCAP file per process. This means that if I ping something, then I'll have a PCAP for that command, ping. And then if I ping something else, I'll have another PCAP file for another process. So it's not by command, it's by process the PCAPs are generated. Okay, so it's not IPv4, it's IP. It's not ICMP. Just a second. Here. So if I run this command, I'm capturing everything. And if I find something, you can see that since I have Node running in my server and I have SSH running in my server, I have captures by proxy. So if I do a ping, you can see that there will be a ping PCAP file. And if I do another ping, there will be another ping capture file. So I basically captured all the network traffic that happened for that command. If I do curl, I don't know, curl Google, and then I will see like all the packets for curl. So just for you to see, if I do a TCP dump in this file, you can see that, well, let's remove you will see only the ICMP packets because this was the PCAP for the ping, right? And if I do a TCP dump here, all the packets related to the HTTP query only because this is just for curl, right? And another cool thing is that if I run, let's say, a container, as you can see, there is no container files, but by the time I do a ping here, you can see that there is a PCAP file for the ping that has run into this container, right? Because I'm creating like one PCAP per process, right? So remember this because I'll change the behavior soon. So if I do curl google.com in another container, you will see that here there were two processes for curl. Not sure why, maybe like it created like another process. So and if I like go to Docker and in that container I ping something, you will see that it created like the ping PCAP file. So it's basically all the processes that are spawned into your server, being on the host or being inside the container. You have one PCAP file for it, and you capture all the traffic for that process. Okay, so now instead of capturing by process, I'm going to capture by command. What is the difference? The difference is that if I execute ping one time, it will have a PCAP file for ping. If I execute ping for the second time, it will append to that file the other ping because I'm doing by command, right? So let's show this. So if I do ping here, we'll see there is a ping PCAP file on the host, right? And if I ping something else, well, let's do a TCP dump there. TCP dump into this file here. You can see I'm pinging 1.1.1, right? And then now I'm going to ping 8.8.8. And you can read that file again. You will see 8.8.8. So I can have one pcap file per command executed. And if I go to the container that we had opened and I ping, and then I ping 888, okay, and then I can see that it was a file created for that command inside the container 86E8, blah, blah, blah. And then I can read the pcap file from the container. And you will see that I pinged 1.1, I pinged 8.8. So this is like capturing by command, right? And then I can combine. So I could capture, for example, by process, by command, by container, and having a single file altogether. And by the time I do this, you will see that it starts creating all those files for me. So I have a per command pcap file. I have a single pcap file containing all the traffic. I have like process pcap file, and I have a single pcap file for the container as well. So if I do this, you will see that, let's see, 1.1. So I have the ping here, right, on the host. And if I do ping again, I have a second ping on the host, right? And so because I'm creating one per process, but I'm also creating one per command. So the same contents that I have in this file plus this file will be in here. So it's easier for you to do some introspection. You know exactly what is going on and what is the traffic in your server. And I have also per container, all the traffic per container. So if I do like curl google.com and then ping and then let's look up. Oh, I don't have dig. I'm not sure if I have. Okay, whatever. Ping. Let's do a ping for the name. And then if I do this, you will see that I have a pcap file for the container and I have a pcap file for curl for in that container, and I have a pcap file for ping in that container as well. Okay, with that said, now the last feature of network capturing is related to length of what is being captured. I don't want to go like into too many details, but the idea is that if you're capturing all the traffic, you can choose if you're what to capture. So you could capture only the headers from the packets, or you could choose how many bytes from each packet you would like to capture. Or if you want to capture like the full packet, right? So let's say that you're capturing like this, you would capture TCP, right? And if I'm doing this and I pass this argument, snap length max, it will capture the entire packet. Or maybe not. Let's copy the command. It's easier here. Oh. So sorry. Okay, so I had an error for. So if I'm capturing everything and I put length equals max, I'm going to capture the entire packets. But that is not very good, right? Because let's say that I'm doing wget into an ISO, for example. It will start downloading the ISO. And as you can see, the wget pcat file will become larger and larger and larger. So you can see it's growing a lot because it's capturing the entire packets for all the transfer from the ISO, right? So that's not a good behavior. But I could say, for example, instead of capturing that, capture only, I don't know, let's capture only the 90 bytes from the packets, right? And then by the time I do a wget, you can see that it grows, oops, it grows much slower, the file. It's only 3 megabytes because I'm capturing only 9 bytes per packet. Or if I want to introspect only headers, I could simply do this and put header in here. Oops, headers. And then I'm only capturing headers. So let me do a wget. And then as you can see, the file is just 1 megabyte now. It's very little. So if I do a TCP dump into the file, as you can see, it's like you can see all the packets, but the length of the packet is 0. So it's basically you're seeing only the headers in the TCP dump. I think that's it. So I showed all the features in the network capturing feature. So
Awesome. Thank you. If there are any questions by anybody watching right now, you can either ask in the live chat and we will answer them right now live, or you can join the Slack community and ask in the Tracee channel. Now, there's one question which was not directly related to networking, so I reserved it for now. Icarus is asking, is it reasonable to use Tracee to monitor everything in a container? Think run an untrusted binary which creates lots of processes. Will information be dropped, for example, because of lack of buffers?
Well, Tracee is designed to handle very big amounts of data, and it was we always try to see and check performance and see if we get dropped events. So it's correct that events can be dropped, but it's kind of a problem of producer consumer, right? So if you choose many events, okay, and Tracee allows you to choose many, so it depends how many events you choose, and it depends how many workloads you have. So if you have a lot of workloads and a lot of events, so you produce many events, and as a consumer, Tracee needs to consume all of these events and process them. So eventually, events can be dropped. That's correct. So for that, one thing that can be done is to change the buffer size, and then if you have bursts, it can be handled by having larger perf buffers, and Tracee allows you to set the perf buffer size through the command line. But again, this will only handle bursts, and if the events are being produced much faster than consumed, eventually they will be dropped. So the solution to that will probably be to have less events or more filters to filter for specific workloads and not everything on your host.
But this is not just specific to Tracee, right? This is with any monitoring tools such as Tracee. What do you say, monitoring?
Yeah, so
where it can
that's
happen, right? Just to iterate on that. No.
Whenever you so you need a way to pass the event from kernel to user space, because when you print the events in user space, they have to go through from kernel to user space, and it goes through these perf buffers we spoke about. So it doesn't matter which tool you use. If the event is being printed or monitored and eventually gets to the user, it needs to be passed through these perf buffers.
Makes sense. Awesome. Thank you for answering. If there are any other questions in the chat of those people who are watching right now, thank you for watching. Please do ask the questions in the live chat, and we will answer them right now. Otherwise, do join the Slack community. I would have a question. How do you see the new Tracee experience evolving? And is there anything that people can contribute to the new experience? Whether that's feedback or providing policies that they're writing for the community, or just to provide some examples. What can people do if they want to get involved but don't not to contribute to the code, for example, or from a user perspective? Like those two questions: how do you see it evolving, and what can people do from a user perspective to contribute? Somebody else, not Yanni. Raphael, Jason, what would you like to see?
So
what would you like people to do now?
I've been talking to people testing Tracee, and they're very interested in writing signatures for their own purposes. So we are currently pointing people to write their signatures in Golang, but that will soon be changed. Of course, we do support Rego, and like we have an experience with GoCell signatures, but that will also be very important for what Jose and Jason showed on the policy side, because that would allow you to create your signatures and create your own policies, etc. So that's something like I've been talking to community and getting a lot.
Awesome. And how is this experience gonna evolve in the next releases?
I believe that allowing users to write signatures, it's a benefit for them. They could give to Kubernetes and filter for specific things that are not part of the default signatures. The idea of the default signatures is to provide as much as we can, for security purposes. But you could, for example, monitor access to a file that we're not considering and things like that.
Okay, awesome. Anything anybody wants to add? Or if there are any questions from...
Yeah, I think policy is really changing the way Tracee used to be. It's a different user experience. I think that people can probably add more policies if they like to contribute to the open source. Then also it's possible to add the examples policies. And of course, we want to hear feedback from anyone who has feedback about the user experience. If there are things we can improve, anytime we are glad to hear any feedback and improve if we can.
Awesome. Well, there are no more questions in the chat. So if you're watching this, either right now live or the recording, do join our Slack community and ask the questions, anything that you might think of that's unclear, either there in the Tracee channel or ask them through an issue or GitHub discussion. All the links are here provided, or you can find them on Aqua Security, GitHub, Tracee. Yeah, thank you everybody for watching. Thank you for the Tracee team, for joining this live stream and answering questions live and providing the demos. If you would like to see more of these live streams, please do let us know. This is the second one or the third one that we're hosting around Tracee. So we are happy to host more, but we need your feedback that you actually want to see more of these live streams. So please do let us know, because we rely on this feedback to kind of prioritize events and types of events that you would like to see. If you would like to see a different type of structure of events, then please also do let us know. Now, do check out Tracee, give it a try, give the new experience a try, and give it a star on GitHub. If you enjoy it, or if you don't enjoy it, then let us know why you don't enjoy it, and give us a star anyways. Anyway, thank you for joining. Thank you everybody from the team, and for those watching live, I hope you have a great day, and to see you in the next live stream or event.
Thank you.
Bye-bye.
Thank you. Bye,
Bye.
folks.